How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at 16.5 practice problems on strong acids and bases. So number one, nitric acid is a strong acid. That means that blank. Does it mean that solutions of HNO3 contain equal concentrations of H plus and OH minus? No. So what's it mean to be a strong acid? It means that it will completely ionize. So if we have HNO3 and we dissolve it in water, every single one of those molecules will break up into the ions. We'll have H plus and NO3 minus dissolved in water entirely. And that's what makes it a strong acid. So B, it does not dissociate at all in water. Incorrect. It dissociates completely to H plus and NO3 minus when dissolved in water. Yes. And D, it produces a gas when it is neutralized. That has nothing to do with whether or not it's a strong acid. And it cannot be neutralized by a weak base. That is, no, that's not true. All right, number two, of the following acids, blank is not a strong acid. The only one that's not a strong acid here is this HNO2. The rest of these are strong acids. A little bit of memorization to go with those. All right, what is the pH of a 6.73 times 10 to the minus 2 molar solution of HI? So we take a look at HI and we know that it is a strong acid. I got to go, well, what is pH? pH is equal to the negative log of the H plus ion concentration. Now, since HI is a strong acid, it will completely dissociate. So the concentration of HI is the concentration of H plus. So we do a little plugging and chugging. We do negative log of 6.73 times 10 to the second, or negative 2 rather, and we get a pH of 1.17. There you go. Number four, what is the pOH of this molar solution of HBr? So here is the little issue. We got a strong acid and they want the pOH. So we got to remember that when we do pH added to the pOH, they add up to be 14. So if I'm trying to get pOH, I do a little algebra. I get pOH equals 14 minus the pH, where the pH is the negative log of H plus concentration. So again, if I have a strong acid, its concentration is the H plus ion concentration because it dissociates completely. So I do a little plugging and chugging. 14 minus the negative log of 8.23 times 10 to the minus 4 molar, and I end up with, what do I get? 10.92 as my pOH for that solution. All right, number five, what is the pH of a 5.91 times 10 to the minus 1 molar solution of KOH? All right, same kind of issue here. They gave me a strong base, and they want the pH. So again, all right, well, I know that pH plus pOH has to equal 14. And they're giving me a base. All right, so I got to solve for pH. I get pH equals 14 minus pOH, which is the negative log of the OH minus ion concentration. Now, if this is a strong base with one hydroxide, that means this concentration is the concentration of the hydroxide ion. So I go, all right, 14 minus the negative log of 5.91 times 10 to the minus 1 molar. And when I pick up my calculator, beep, pop, boop, I end up with 13.8 as my pH for that solution. 6, what is the pOH of this concentration CSOH? All right, so this is another strong base, and this time they want the pOH. Well, if it's a strong base, that means it completely dissociates, and I get 1 OH minus. So the concentration of that compound is the concentration of my OH minus. So pOH equals negative log of the OH minus the hydroxide ion concentration. So I just plug and chug negative log of 3.48 times 10 to the minus 3. And I pick up my handy dandy calculator, beep, pop, boop, and I end up with 2.5 as my answer for that. All right, number 7. What is the pH of an 8.32 times 10 to the minus 4 molar solution of calcium hydroxide? Now, this is a strong base that's giving us 2 OH minuses. So it will dissociate completely and give me 2 OH minuses for every CaOH2. So the OH minus the hydroxide ion concentration is going to equal 2 times the concentration of that calcium hydroxide, because you have 2 OHs for each of them. So I do 2 times that, so 2 times 8.32 times 10 to the minus 4 gives me, you know what, I don't like this in between math. I'm just going to use this. So if it wants the pH, I know that pH plus the pOH has to equal 14. So my pH equals 14 minus my pOH, which means it's equal to 14 minus the negative log of the OH minus ion concentration, which is this 2 times 8.32 times 10 to the minus 4 molar. So now I pick up my handy dandy calculator, beep bop, boop, and I end up with 11.2. So if there was a way I guessed, if I had to guess if you got it wrong, where you went wrong, you probably forgot to account for the fact that it's dihydroxide. You have 2 OH minuses there. All right, I hope you found that helpful. See you in class. Okay, bye.